Uh, Hi. Okay. Oh, let me just angle my camera better towards me. Hey man, come on. Uh, I am wearing this. Okay, I, so I'm wearing this tank top because it's like 40 degrees out there and too much heat, bro. I just came home from gym and just I was setting up my phone and SCR copy for this tablet, right? And I do not know if we are live or not. Let me check real quick. Yes, it shows live and live. Yep. Oh, okay. That's way too loud, by too loud, too loud, too loud, too loud, too loud. Yep. Is it better? Oh, okay. That's way too loud, right? Loud, too loud, too loud, too loud, too loud. Okay, so I just got a haircut, new haircut, and it's too much heat, so I'll just go ahead and like my own video. And let's start with what. Okay, so this is today's contest. I was hoping that I could solve this. Okay, let me get my tablet out, and tablet is yeah. So I installed multiple apps, right? Let's see. The first question is I will take the DSA practice and no, I want to go to 88. I believe my tablet is oh, okay, right. The screen is stuck. Yeah. Hmm. Why is it? Yep. Okay. Now just or I can just put it here instead. It will just show up here and like yeah, there's just hmm. SCR copy is being too. Let's just keep it here. Bro, can you please not do that, bro? Oh, that will also resize. Uh, I need to keep it something like that. It does not have to be out of window. Yes. Uh, uh, no, do not shift the video. Oh man, this is so weird setting this up. Okay, so this is my tablet over here, right? And let's just put the display on topmost. Oh, oh, tablet will go up and droid cam also up. Yeah, right. Okay. So I believe everything is set up. Yeah. So let's start. Pull to add page, huh? I'm, I'm going out of frame. I should not. Okay, so let's see what. Too much clutter here. Right. Oh, what the? Yes, that is better. Please keyboard shift to side and yes, tablet and yes. Uh, okay, so wonderful contest, right? None savor sound. What? What does that mean, bro? Oh, okay. Just wait. So a person who loves competitions and you need to participate in a wonderful OL contest, OI contest. I don't know what that means. This contest has n problems, each with a full score of 100. Uh, okay, so hmm, each with a full score of 100. And I think I am again cut. Yes, I think that is better. Yep, I am still not okay. I should shift to this side. Right. Perfect. Perfect. Couldn't be more perfect. Right. Okay. How do these people do this? Why? This is so damn. Right. Contest has n problems. Right. N problems, and you need to participate in a wonderful O contest. The contest has n problems, each with a full score of 100. Okay, so 100 is max score. Right? Okay, and the ith problem has AI subtasks. Okay, for I, there is AI subtasks, and each subtask has a score of 100. Right? So for each of that is 100 divided by AI. The tablet is getting hot. I will just quickly disconnect it and connect it back, removing the cover. Yep. This is how my tablet looks like. It's a Motorola. I love it. Finally paid its EMI completely. Right. Do I need to set it up once again? Yep. That's done. Okay. 100 by AI. I'm not pretty sure that I can do this question, but I will just go ahead and try. Yep. So let's just no, don't do not put it there. Just slowly. No, bro. Oh my god, Windows is such crap. Fuck this. Right, okay. 100 out of AI for every set task. Okay, so it is a divisor. If anyone is not Hindu, oh man. Okay, right. If anyone is not Hindu, feel free to go about your day, but I will write that. Be careful, there is a 50-point penalty for some submission which fails the pre-test or resubmission. What? Damn, bro. Okay. Oh man, this looks like too much information, but let's just. So now several contestants will participate in the contest. Okay. Suppose a contestant solves xi, x of I, which will be 0 less than x of I, which will be less than a of I subtasks of the ith problem. His score on the ith problem will be, okay, so his score will come out to be xi into 100 divided by a of I. Okay. The total score of the contestant in the contest is the sum of score on the on all problems, that is summation of this, right, from I equals to 1 to n, however much it solves. ठीक है, समझ रहा हूँ थोड़ा बहुत. To prove that the contest is a truly wonderful one, you have to check whether it is possible to achieve every integer total score from 0 to 100 into n inclusive. Which k, ठीक है, every integer k, their existence array First test contains, let's just go to test cases and I will figure it out from there. So डकार आ रही थी. So for each test case, output yes if it is possible to obtain an arbitrary total score between this. Otherwise, output no. In the first test case, for every integer 0 to k200, it is possible to achieve a total score of exactly k. For when k is equal to 10, contestant who passes 0 subtasks in the first problem and 2 subtasks in the second problem achieves a total score of this 10 k. In the second test case, when k is equals to 95, it can be proven that it is impossible to achieve a score of exactly 95. No, acha. And in the third test case, I have no idea. I'll be very honest. I do not get this. I'm so far behind. I will just not do that. Okay, so it was a wonderful week. I will just remove this tablet for a second and we will talk about what's happening. So it was a wonderful week, man. Come on. I gave the TCS interview and it did not go well. So I was given digital role, right? But what to say? I think that they will demote me to ninja, but I have to get a job, right? Because sitting at home is very, very depressing. And I got the Infosys questionnaire, and I will be doing that. And I got one more assignment from a company. I will not name it, but it's a good company. They are offering like they are hiring for a founding engineer. I do not know that I am a founding engineer material or not, but like I have a lot of technical knowledge and depth. But still, okay. Also, there's one more good news, but I will definitely would love if that that opportunity converts, and then I will announce that, right? So this was a wonderful week, right? I will just go through what I did this week. So let's go to DSA sheet and then. So this week I learned what I learned. Breadth first search and DSU, and so I'm following this YouTube. This person, I will just go ahead and decrease myself. Yes, right. Okay. Okay. This is not the account that I use. Switch account, and I used this for learning. I generally do it. Amazon employee after 1 year. Damn, she's cute. Okay. Learning Java. Why is people okay? Yep. I do not want this, bro. Do not give me breaking news, bro. HTTP from scratch. Whoa. Google. Only girls are getting hired, man. Come on. Give us boys chances, man. Please, come on. What the? I mean, I like his enthusiasm, but why are you not playing outside with children and instead you are what is this guy doing? He's doing lead code, man. Yeah, this child should touch grass. Too late, bro. Too late. I just gave up for that. I am keep learning. I will keep learning C++ and stuff. I'm going deep and learning about Linux kernel development also. But I just gave up on that. Not give up, but I need more time to actually. So there's a book that I got for myself, and it is in content share, I guess. Right, I will just. Oh, okay. My Telegram is not showing up. That's good. That's good. I do not want that. So this is the book. I will open up it right now. Yes. Redmi Note 9 is the phone that I have connected to, and uh, it should be in downloads, right? Yep. Telegram desktop and I'm just clearing out my other resumes so that you guys don't. So this is the book. It's by Michael Karzik. It's a Linux and Unix system programming handbook. I to be honest, I will not be. I will try to cover this book, but it's very very vast. You can see that it's like 65 chapters, 150, 1500 pages. Man, come on. So I have some things that I will be doing. Something like system programming concepts. First of all, I need system call, how they work, and we'll do that. So it's a control entry point into a kernel, allowing process to request the kernel perform to action. So basically, this book's about Linux and how things get done in Linux, file I/O and memory allocation, which is BRK and SBRK. Oh, okay. There's a C++ code also. Oh my god, that's jam, bro. Allocating Oh, C programs use malloc. Okay, that's C code. Oh, Unix system has provided from damn. That's good. Time, and what is time? Real time, process time. Oh, calendar time, process creation, fork, exit wait. These are the concepts that we learn in computer science degrees. So that's good, man. That's good. Okay. In computer science, you learn about this fork, exit wait, and I just did that for. Is there too much noise? Oh, okay. Because the cooler is here and I am using it. So also I got this. It's a mantra job. Okay. So okay. That's nice. I will be reading this. Okay. And that's just where was I? Oh. Why is there so much hmm. Okay, so this week I learned about DSU. Yes, was trying to do this, how to build a distributed file storage. That's good, yeah. Tuesday I was doing graph bipartite, and this was the center that I was allotted, TCS Noida, sector 157 near the Chatta village, I think, and it was like very there was a very small building where we guys was at. Not small, but in comparison to the whole campus, it was a small part. So it is still not completed. And Sunday is graph bipart. Okay, so let's talk about today's graph bipartiteness. What does bipartite means? I will just include my tablet, and it's switched off. Yep. Nice. It covered my. Okay. Yep. So I was doing that in this one. Graph bipartite. Yep. So it is there, I guess. Cons algorithm also I did. Right. I will just go ahead and do that bipartite. Yep. I think it will be here. Interview, DSA. I do not use these other apps because I do not like them. I like this one the most. So graph bipartite is here. core schedule, function, topological sort. See, yeah, it's just we'll take the rough copy and start. So what does it mean by a graph being bipartite? So I'll just say, what does bipartite means? Bipartite. It means that if we are given with a this card eyes, it vary with that. Okay. Is it visible? Yep. I can also do this, but it would go out of screen. Yes. So if we are given a graph, right, and this is a this is a graph, and we have, let's just use this color so that it's a neutral color. This is a graph, and we can say 0, 1, 2. It's an undirected graph. So okay, and if we have red as 1, okay, it's red, and if we have 0 as blue, then if we color any one of the node, let's start with 0, and I color it with the blue, so 0, and we have to see that if it's adjacent, right, adjacent neighbor, right, oh, okay, so I can use this, right, so here, so here, this is our graph that we made, because here I have laser pointer, so I will use that. So here we can say that this graph, I can change the color to like any good color. There are less of the good colors here. Nah, not about that. Any color, man. Come on, give me a good color. Yeah. Okay. So if we go ahead and say that 1 is for red, yes, and blue is 0. Yep. So, and if you go ahead and start with the blue and color it 0. So if now you can see that this is, and its adjacent is this one, right? So it is not colored yet, right? It is not colored. So what we can do is we can just go ahead and color it with a different color, the red one. Okay, can just go ahead and color it. Okay, now we are standing here. So okay, we are standing here. We can see that this person, does it have the same color as us? No, it does not, right? So okay, again, and does this have, say, there's no color, right? So you can just go ahead and say that, go ahead and be blue colored. Okay, so we can say 0, and we can say 1. Right now we have to see that this person's adjacent one is a different color, and this person's adjacent one is different color. This person's adjacent one has a different color, right? If we are sitting here, then this has a different color, and there's no other node, right? But if there were to be another node and it were to be a blue color, then we would not say that it would be a bipartite. No, it would be not, right? But this graph is a bipartite graph. Yes, this was the bipartite text. Okay, that's about bipartite, and it's used in multiple cases. It's a very, very good one, right? What else did I study? Disjoint sets units and DSU graph bipartite. There are questions also. I can do questions if you like, but like I just explained the concept. You can go ahead. Also did BFS, cycle and directed graph, even DFS and 3 idiots. Huh? But that was full. Oh, okay. So resilient token protocol. Whoa. Disjoint set unit. Oh man, that's this DSU was very very good, man. Come on. So we can talk about also about disjoint set unit, right? Not unit, union. So it says that this joint set, make it a set and do a union. What does that mean? Disjoint word, right? We can start by explaining disjoint. So if we take two sets, the set one, set two. If you remember sets in mathematics way back, no? So if there are two sets which do not connect at all, right? They are disjoint sets, right? Disjoint. Okay. And S1 and intersection S2, if we do, it's a phi or null. Yep. So how does this help us? Wait. Keep in mind that I'm just explaining this. So we talked about sets. To get disjoint set is done. Union is that we need to unionize it, right? Okay. So there are two things that you have to do in DSU, right? First is find. Yes, you need to find the parent. Find parent of a graph, of a node. Right? Okay. And then you have to do a union. Do a union. Right? It's easy one, man. Come on. So if we take a small graph, like something like 0, there's a 1, there's a 2, there's a 3, there's a 4, right? I can say that we have parent. So I did a question today. It was on GFG. GFG DSU. This is the question. I need to log in to do that. I have no idea. GFG account. I think it may be logged with GitHub. Bad request. Yes. Okay. So I don't know, man. Come on. So this was the question, though, right? This is the question. And in it there were like instead of parent they are using the language representative. Instead of parent they are using the language representative, right? So same thing. Okay. So by pure logic, we can say that who is the representative or a parent of 0? It is 0 itself, right? So 0, 1, 2, 3, 4. These are indexes also used as nodes. So 0's parents is itself 1, 2, 3, and 4. Okay. What are we doing here? Right. First, we need to find the parent of the node. So something like integer. It's a very, very easy find, right? We can take the integer, let's say I, and we will get the vector, right? Integer. You know the drill. Get the parent array. Yep. You need to write a very, very small function for integer I equals to 0 and I will be less than this n equal to, right, and increment I, and you can just go ahead and parent at the position I will be I itself, right? This is more than enough to just fill up the array. And in this we can say if, right, if we call the find function on a node, right, we can say that if parent at the position I, right, parent at the position I, right, is itself, right, parent at the position I is itself, then who is the parent? the guy himself. Yeah. So it takes times to get these shortcuts in this different apps. That is why I do not use multiple apps. So we can just go ahead and return the parent. We needed parent, right? So we found the parent. Yep. And if we do not, then we can just go ahead and say return, right? What? Find function. We are doing recursion, and parent at the position I and parent array. If we found like its parent was like let's say 1, right? So this will be would have been 1. Yep. So parent at the position I, parent at the position I. Okay. So 1. So find function will go. I can do a stack trace for you. Let's just okay. I will do the stack trace for you. So find p gets called with 0, and the array will not do that. It will go, and if we'll see, it is not at the position I is not equal to I. Okay. I don't know. Parent at the position 0, is it equal to 0? No, it is not. No, it is not, right? Okay. So that is why this line will get implemented, and find p. We are using find, though we will not use p. Okay, and find, it will get called with parent at the position I. Who is this? This 1. Okay, and it will go and see who is at the parent I. Now again, if parent equal to I, now parent at the position 1 is equal to 1. Okay, yes, it will return I. It will come back with 1, and this will at the end of the day return 1. Okay, that is how we find parent. So we can do a, there's something called path compression, right? We will talk about why it works. So let's assume that this we got the something like, we have this graph 0, right, and then it goes to its parent is 2, right, and that it goes to 3, and then its parent is something like that, right? This is a very weird path, right? We have to go to this and this and this, and eventually we will know that its parent is 3. Yes. So we can apply path compression on this. There will be nothing a lot of changes, but instead we can just go ahead and isn't there an option to copy? Instead of this, there will be a very small change, right? Very small change. We will just say parent at the position I would be this. Simple. What this code will do, I'll just explain it, right? What this code will do is it will go and see that its parent is eventually 3. Then all of these will become a one lined one, right? So it will be like, so there was 1, right, there was 2, and there was 0. All of them will be pointing to this. This would become the, it's called something like it has a very good name. I forgot the name, right? It's called something like Ackman constant, I guess. Ackman something, right? And this would give, right, alpha and n, right, of this. So it would be like constant time, around constant time, right? So how our performance became from going to O of n, it became to an Ackman. This is called an Ackman constant or something. I do not remember what it was, but this would give us approximately O of 1 time for that. Yep. It will also go ahead and update parent element here. So that would also be get updated here. Okay, and uh, that is about it for this video. I believe my family is calling me for dinner, and it's almost half hour for this video. Okay, so let's meet you again in the upcoming videos and keep coding. And so yeah, I will just write something. Jai Shri. Keep this in your mind, and I will meet you in another